Hi everyone, welcome to this data annotation course. I'm your instructor, and today we're diving into the first part of the material. Hope you're ready, let's get started.
In this chapter of the Artificial Intelligence Technology Application Core Course series of textbooks, we will explore image data annotation. We'll start with an introduction to it, then move on to the key point marking method, the marking box marking method, and the image area labeling method. After that, we'll summarize this chapter, and finally, there will be assignments and exercises. Key point labeling means identifying key points by indicating the elements to be labeled at the required locations. Currently, in many application scenarios, a large number of images need to be annotated with key points. We obtain the annotated data and use it to complete relevant tasks. At present, we mainly rely on manual methods for this. As the name implies, annotators mark key points at defined locations. This type of annotation is often used for statistical models, as well as pose or face recognition models. Statistical models, like a mall foot traffic one, use key point annotations to represent the density of target objects in a specific scene. Pose or facial recognition models use these annotations to understand the movement trajectory of points in motion and judge the uniqueness of a person in the picture through point annotations in different directions, enabling more complex judgments. Key point annotation is commonly used in areas such as face recognition, human bone detection, and gesture confirmation. With the continuous maturation of face recognition technology, market demand is accelerating, and application scenarios are being continuously explored. Face recognition is expanding its application market at all levels, from social security collection to campus access control, and from remote pre-authorization to security gate inspection. The rapid popularization of face recognition applications is bringing new development trends to the industry. The booming face recognition market and its expanding application scenarios are mainly due to technical innovation. Deep learning has improved the accuracy of face recognition to a near naked eye level, enriching its application scenarios. The need for remote internet bank account opening has brought face recognition into financial level application scenarios. Giant's frequent layout of face recognition gives it more potential in application scenarios, and cultivating users' face habits and recognition of the technology is beneficial to the industry's further development. The joint promotion of multiple parties has led to the explosive development of face recognition applications. Key point annotation is typically applied to human face outlines, 5 sense positioning, body parts, and animal heads. Its most significant application is in marking key points on human face outlines, hands, and human bodies. By using key point annotation, we can determine the function of the person in the picture. For example, there are 21 key points marked on the palm and 68 on the face. First, let's talk about the data naming format. The image naming format is image name _ gender _ age _ ethnicity _ hat, wearing state _ glasses, wearing state _ background. For instance, it could be like 00091 _ female _ juvenile _ yellow _ wearing _ hat _ with _ plain _ colorless _ glasses _ indoor. Second, regarding metadata processing, each annotated image needs to generate corresponding data tags, and some metadata are shown in the figure. Third, we come to the data storage structure. The complete data storage structure is presented in the figure. This section introduces a sample of Datatan's key point annotation tool. Its main application is in human face point annotation. By marking points in different directions, we can judge the function of the person in the picture. Common point annotations include 106-point face annotation, 21-point gesture annotation, etc. The labeled picture types include common human faces, features, and parts, and animal heads. The number of key points commonly used are 18, 22, 64, 106, 128. Point properties can be visible points, invisible points, or predicted points. Image attributes include background, angle, action name, gender, etc. The Markup Tools layout. The markup page is divided into three main areas. The drawing selection area is used to display pictures and specific typing labels. The tools area shows all the tools needed for zooming in and out during the marking process. The label area, which distinguishes layers, displays the annotation content. The labeling method. First, for marking points, click with the mouse on parts like the nose and eyes in order. Second, to edit points, click the corresponding edit button of the organ in the label list area. Third, to delete points, click the delete button of the organ in the label list area. The key point labeling interface is shown in the figure. The project background here is that image processing serves as data support for mouth recognition applications. The marking needs are to mark the diplomatic nodes of the upper and lower lips, the intersection of the upper and lower inner lips, and the equivocal points of the lower lips. The key point locations are described in the following table. The marking specifications state that for special cases where the location can't be seen visually on the picture, supplement according to imagination and mark the key points at the predicted exact location. Points 1 and 2 should be strictly at the corners of the mouth. Points 3, 4, 5, 6, 7 should be strictly on the border of the outer edge of the lower lip. If the lip color or the outer edge border line is not obvious, the point can be drawn a bit higher. When the mouth is wide open, points 8, 9 should not exceed points 1, 2, even if they are close or overlapping. When the lips are obscured, draw the corresponding points by imaginary prediction without adding an obscured marker. Skip the figure if there is no pre-labeled result. The acceptance criteria require the key points to fit closely, be in line with the actual situation, and be marked with 99% accuracy. The markup output includes the original image, JSON, and the effect image. Although key point annotation seems relatively simple as it only involves marking points, its implementation is actually quite difficult. It's a high-difficulty annotation task in picture annotation. Firstly, there are usually many key points. During labeling, one needs to understand the meaning of dozens or even over 100 points, and it's easy to make mistakes when there are so many. Secondly, the criteria for judging the marker's qualification are not very clear, making it hard for the marker to check their mistakes. With so many marked points, it's not easy to find a point that deviates from its position in time. After all, humans are not machines, and finding equal points between 2 points by the naked eye is challenging. In face key point annotation projects, the annotated face pictures are usually 2-dimensional, but annotators are required to have a 3-dimensional sense of the pictures with a 3-dimensional effect. When encountering obscured or invisible points, annotators need rich spatial imagination during annotation. Generally, key point marking requires markers with high-quality skills, and some practitioners even consider it more like creating artworks rather than just marking work.